Good evening, everyone. Today, let's start the live session for the week 7 of Advanced Concrete Technology. Let me share the screen. Yeah. Is my screen visible to you? Yeah, I hope that's visible. Yeah, thank you. So, welcome again. So, today we have a very short session. And without further ado, let's move into the question and answers without further delay. So, the first question, in week 7, we dealt with different mineral admixtures, different test methods through which we can test for their effectiveness, etc. So, the first question is choose the correct statement with respect to the carbonation depth in cement concrete at a particular age. So, at a particular age, carbonation depth of slag cement concrete is equal to the carbonation depth of OPC concrete. Second statement is carbonation depth of the slag cement concrete is less than the carbonation depth of OPC concrete. Now, the third statement is the carbonation depth of slag cement concrete is greater than the carbonation depth of OPC concrete. So make sure that it is at a particular age. At one particular age, what is the difference in the carbonation depth of slag cement concrete and OPC concrete? I'll again post this question in the chat box. You have to basically choose the correct statement. So, slag cement concrete contains slag, whereas OPC is plain ordinary Portland cement. So, what is the difference in the carbonation depth? I encourage you to please respond to the question. Whether it is wrong, it's not at all an issue. This is a learning platform. So, I'd encourage every one of you to answer. Okay, so moving on to the answer. The correct answer is C because at a particular age, in with relation to the slag cement concrete, it would have utilized more calcium hydroxide of the system for the pozzolanic reaction, right? So whatever lime or potlandate or calcium hydroxide was available on the system, it was used by the slag or the reactive silica in the slag for the pozzolanic reaction. Then what happens is when the carbon dioxide attacks the system, it will not have the sacrificial layer of calcium hydroxide, or it will not have the easily attacking layer of calcium hydroxide. Instead, it will attack the calcium silicate hydrate. So what happens is that the calcium carbonate will be formed towards to the inner layer. There won't be much of calcium hydroxide to prevent further carbonation. So that's the reason in the case of OPC concrete, that Portlandate or the calcium hydroxide is still there. It is not utilized for the pozzolanic reaction. So if X amount of Portlandate is available in the OPC system, there will be less than X amount in the case of slag cement. So this is very bad in the case of carbonation. So the carbonation depth actually increases in the case of SEM added concrete or mineral admixtures added concrete. So that is why the correct answer is C. Moving on to the next question. Rice husk ash is obtained by the dash of rice husk. Options are controlled oxidation, controlled reduction, controlled calcination, and controlled hydration. So, in ideal cases, when not ideal, in the usual cases on the open fields, it's not at all controlled; it is uncontrolled. But for the laboratory purposes and for the research and production purposes, rice husk ash is produced in a controlled manner. So, what is controlled? Controlled oxidation, of rice husk, or controlled reduction of rice husk, or controlled calcination or controlled hydration? I'll wait for a few seconds. Okay. So the correct answer is controlled calcination. So rice husk is basically incinerated, or it is heated up. In that case, what happens is calcination. So it undergoes controlled calcination and forms the rice husk ash. Move to the next question. So here we have two statements, and based on those two statements, you have to choose the correct option. So the options are or the question is as follows. Option A, rice husk ash, or the statement A, rice husk ash calcined at very high temperature more than optimum results in increase in crystallinity. And statement B, higher crystallinity results in increased reactivity of rice husk ash. Again, statement A, it states that if you increase the temperature of incineration or calcination of rice husk ash beyond a limit, more and more heat is being provided, then it increases the crystallinity of rice husk ash. And statement B states that higher the crystallinity, higher the reactivity. And regarding these two statements, the options are statement A is true but B is false. Option B states A is false but B is true. C states both A and B are false. D states both A and B are true. Again, I'll give a few seconds. Okay. Thank you, Ria, for responding to the question. Let me give a few more seconds for someone to read the question properly. A states rices gas at very high temperature calcination results in increased crystallinity. Option B states crystallinity increases, reactivity increases. So, what is the correct answer? Okay, we move to the answer. Correct answer is A. That is, A is true but B is false. So, statement A is true. That is, rises cat ash when we increase the when we increase the calcination temperature, crystallinity increases. Now, option B states that higher the crystallinity, higher the reactivity is a wrong statement, because we have been talking about reactive silica, the need for reactive silica in the mineral admixture for pozzolanic reactivity, right? So, the reactive silica is the amorphous silica, not the crystalline silica. This is exactly what happens when you uncontrollably heat or burn the rice husk. When you uncontrollably burn the rice husk ash, it becomes more and more crystalline, not amorphous. For it to be amorphous, there is a particular temperature and a particular duration at which it has to be burnt to retain the amorphous nature. As long as the silica is amorphous, it is reactive. So the B statement, higher crystallinity results in higher reactivity, is a wrong statement. Higher amorphous nature or lower crystallinity results in the increased reactivity. So they are not directly related, they are indirectly related. So higher crystallinity relates to lower reactivity. Okay, that is why A is true and B is false. Now, moving on to the next question. The technique which is used to measure the specific surface area of rice husk ash is XRD, mercury intrusion porosimetry, Blaine's air permeability, BET. Read the question carefully. It is a rice husk ash. How to measure the specific surface area? Through XRD, through mercury intrusion porosimetry, through Blaine's air permeability, through BET. Okay, the correct answer is B, BET. Why? Because Blaine's air permeability can be used in the case of little bit larger particles. Ricer's cash is very fine particle. In the case of silica fume, Ricer's cash and all, they are very fine particles. Blaine's air permeability cannot be used. First of all, air should permeate through the in between the material's pore structure for the measuring of the surface area of the grains. In between the grains, it should pass. That is not possible because the grains are very small. So, in such cases, through adsorption of the gas, maybe nitrogen or like that, we measure the specific surface area. And the technique is BET. Okay, move to the next question. Aluminosilicates in kyolitic clays get activated when calcined at a temperature above 1500 degrees Celsius, between 1000 and 1500, between 740 and 840, then between 540 and 740. I'll give a few minutes for this. So you have to choose a temperature at which the clays get activated. Okay, fine. We'll move to the correct answer. The correct answer is C, that is between 740 and 840 degrees Celsius. So, kalinitic clays mainly they are composed of aluminates and silicates. For it to react, these aluminates and silicates must be activated. That activation happens at this temperature range. Keep it in mind, 740 and 840. Okay, moving on to the next question. Metakaolin is reactive than slag or fly ash with higher fineness. So basically, the question states that slag and fly ash has higher fineness than metakaolin. Even though they have higher fineness, metakaolin is more reactive than both of them. So is it true or is it false? Okay. Thank you, Ria. Okay, we move to the next. The correct answer. The correct answer is true. Why? Because metakaolin it is very reactive because of the aluminosilicates present in it. Because even though it has a higher fineness, there it is a trade-off. It has it has lower fineness than slag or fly ash. It has large amount of aluminosilicates. Because of that, it has high reactivity. So we move to the next question. Choose the correct options from the below options. It might be just one correct option or more than one correct option. So the options are as follows. Limestone addition to systems containing aluminates result in the form of monosulfates. That is the first statement. So limestone addition to systems containing aluminates result in the form of monosulfates. Second statement is that ettringite when react with excess alumina results in the formation of monosulfates. So ettringite becomes monosulfate when it reacts with excess alumina. Now, the third statement is that ettringite gets stabilized with the addition of limestone. This is a very interesting question. So many concepts are involved in this. So please read each line and then try to understand. Then the last statement says that the density of ettringite is more than that of monosulfates. So you say that it's B is the correct option. Okay. Is there any other option which is correct? Because the question is choose the correct options from below. It might be just one option, maybe, or it can be more than one also. So you don't want to miss that option. It might be more than one. So just read it again, maybe, and then try. Okay. So let's try to understand the answer. Okay. Correct answer is one is B, obviously. Next one is C. So in this case, you might get a partial marking. We have to see, but I think not, because we have to answer both. Then only you'll get. So B and C. So the correct statement. What will be the correct statement for A? Limestone addition to systems containing aluminates result in the form of monocarbonates or hemicarbonates, because excuse me, because limestone is calcium carbonate. How can it reacts with aluminates to form sulfates? It reacts with aluminates and form monocarbonates or hemicarbonates. So because of the same reason, and that is the first statement. So that is a correct statement. Now the second statement, B is correct. Ettringite in the presence of excess alumina converts to monosulfate. That is totally fine. Now the third statement is that ettringite gets stabilized with the addition of limestone. That is a correct statement. So why? Because limestone reacts with the excess aluminates if it is present and becomes monocarbonates or hemicarbonates. Now, ettringite doesn't have any excess alumina to react and form monosulfate, right? Because all the excess alumina or most of the excess alumina has been reacted with limestone to form monosulfate, right? So no longer the excess alumina is available for the ettringite. So it will not convert to monosulfate. It will be stabilized. So ettringite will stay as ettringite itself, or it gets stabilized with the addition of limestone. Now the last statement is density of ettringite is more than that of monosulfate. That is a wrong statement. Density of ettringite is lesser than that of monosulfates. So the volume will be much higher than that of monosulfate. So it expands, or it fills up more volume than that of monosulfates. So the correct statements are B and C. So here the concepts covered are the limestone reacting with alumina, excess aluminates in the system, forming monocarbonate and hemicarbonate, as a result of which excess alumina is not available for the ettringite to convert to monosulfate, as a result of which ettringite gets stabilized. That's all. So moving on to the next one. It's a true or false question. State whether true or false. An increased formation factor indicates enhanced durability of concrete. Yeah. So increased formation factor indicates enhanced durability. Okay, it's a true or false statement. Increased formation factor indicates enhanced durability of the concrete. Yeah. So the correct answer, let's go to the correct answer. Correct answer is true. Why? Because formation factor is the ratio of conductivity of the pore solution to the overall conductivity of the system. So increased formation factor means the overall conductivity of the system is much lesser, which means the system is much compact. There's not much of pores, etc. So as a result, the system is much compact and it has very less conductivity as a whole. As a result, the formation factor is much higher. That case, durability of the concrete increases because the interconnectivity of the pores are lesser. Okay, moving to the next question. In sugarcane bagasse ash, what are the fibrous particles. So, if you see the morphology, or if you see the sugarcane bagasse ash particles under a microscope, there are different types of particles. There are fibrous particles, then there are particles which are looking like spheres, there are prismatic particles, then what else? There are irregular shaped particles. So, each of them indicates something. So, what is a fibrous particle? Okay, moving to the answer. The correct answer is C, that is organic particles. So the fibrous particles are organic particles. If you see here, fibrous particles are organic particles. Then irregular ones are the reactive silica particles. Irregular ones indicate the reactive silica. Then there are spherical particles which are hollow or which are filled, solid spherical particles, and there are prismatic particles. So these prismatic particles indicate the crystallinity. So remember, more the crystallinity, lesser the reactivity. So it has to be more irregular particles or more amorphous particles for the system to be more reactive. So anyway, for the question, the fibrous particles, they are the organic particles which are left behind, that unburned carbon or those organic particles which are left behind in the gas ash. Moving on to the next question. In sodium silicate, sorry, there's no in. Sodium silicate is generally added with sodium hydroxide during alkali activation of calcined clay. 2 dash. That means why sodium silicate is added with sodium hydroxide during the alkali activation of calcined clay. The options are: it controls the reaction temperature. Now, the second option is it reduces the number of polymeric chains. Option C, it improves the dispersion of activators. Or option D, it improves the extent of polymerization. Okay, see, improves the dispersion of activators. Okay, let me see what the correct answer is. Correct answer is D. Why? Because sometimes in the case of calcined clay, in the calcined clay is basically aluminosilicates, right? We saw before that because it has so many aluminates and silicates, it's very reactive. In some cases, the aluminates or silicates will not be sufficient enough in the system for reaction. In those cases, we have to provide additional silica. So, sodium silicate is basically given as a source of additional silica to improve the reaction. What happens if there is a reaction? Reaction is basically polymerization, right? Geopolymerization. So, in the alkali activation of calcined clay, there, that is aluminosilicates. If there is no enough silicates, then we provide additional silicates in the form of sodium silicate to improve the extent of polymerization. This is in the case when the calcined clay doesn't have sufficient silicate to form the polymeric chains. In that case, we provide the additional silica in the form of sodium silicate. Okay, moving on to the next question. The ratio of silica to alumina for the effective formation of polysilate units in geopolymers. So these are the building units in the case of geopolymers, the polysilate units. So it has silica and alumina. So what is the silica to alumina ratio for the effective formation of polysilate? 1 is to 1, 1 is to 2, 2 is to 1, or 1 is to 3? Okay, let's move to the answer. I guess answer is not coming. I mean, no one is replying. So the correct answer, that is a ratio for the effective formation of polysilate units in geopolymers for silica is to alumina is 2 is to 1. Okay, the ratio of silica to alumina for the effective formation of polysilate units is 2 is to 1. Yeah, correct. Yeah. Moving on to the final question for today. Zone 3 in the electrical conductivity test measurement result indicates the setting of a paste. So we measure the conductivity or the electrical conductivity of the paste, and there are, it is divided into, the result can be divided into three or four zones. So zone 3 basically shows the setting of the paste, indicates the setting of the paste. So what will the graph look like? It shows an upward trend, it's parallel to x-axis, or it decreases downward. So this is the last question for today. So zone 3 of the electrical conductivity test measurement result indicates setting of a paste. And what kind of graph is that? It shows an upward trend, it shows a downward trend, or is it a parallel x-axis, parallel to x-axis? Okay. So thanks Ria for responding. Yeah, the correct answer is C, that is, it is decreases downwards. You can see from the graph that this is a conductivity measurement. So the conductivity decreases as the time proceeds, because what happens, more and more of hydration products are forming. The interconnectivity of the pores are being reduced. As a result, there is no pathway for conduction. As a result, the resistivity increases or the conductivity decreases. As a result, it the graph was sloping down. So yeah, today was a very small session. That's all for today. Yeah, thank you all for listening. Thank you for responding. That's very important. Otherwise, it's very monotonous. Yeah. So that's it. All the best for the assignments, and we'll meet for the next week session. That is for the week 8 with more questions. Thank you.
Thank you, ma'am.
Thank you.